Section 5.2, Electron Arrangement in Atoms. Here's our objectives, and please write these down. Put those in your notes. This is going to be what I'm grading, and I'm going to have you answer these at the end, or be able to tell me what you've learned about them. So describe how to write electron configurations for an atom, and why are some of those configurations different than the Aufbau principle predicts. So if we talk about electron configurations, what we're talking about is how do the electrons go into the atom, and they go in such a way that they always take the lowest possible energy. Nature just likes things to be as low as energy as possible, and so the electrons are arranged around the atom, around the nucleus of the atom, in such a way that these configurations are very, very stable, very low energy, and that's what we're talking about. We're going to use three rules to figure this out. The first rule is known as the Aufbau principle. Second one is the Pauli exclusion principle. Third one, Hund's rule. So we're going to use those three to figure it out. So let's talk first about the Aufbau principle. Aufbau principle says that electrons occupy the orbitals of lowest energy first. So if you remember, we were talking about the S sublevel, P sublevel, those kind of things. We have different levels and all those things. The electrons always come into the lowest one, fill that one first. And if we're talking about a sublevel, like if we said like the 2p sublevel, if you remember we looked at the p sublevel yesterday or on the last section, and they were dumbbell shaped kind of orbitals, that's where the electrons usually were. Well, they're all equal energy. All of those p ones were all equal energy. And if we're talking about a principal energy level, PEL, principal energy level, the S sublevels, they're always the lowest. Then the P's, then the D's, then the F's, and so on. And occasionally what happens is these different energy levels actually overlap. And because of that, some levels that are actually farther away from the atom's nucleus are actually lower in energy than some of the other ones. So that's kind of what happens, and that's what makes this a little bit tricky when we try to figure it out. So I always have my own rules for these, and I like to think of it in terms of a hotel, because it just seems to make a lot of sense if I do it that way. And this is what I say: the electrons are cheap, so they go to this hotel. They always buy the cheapest rooms. Now, typically, in most cases, the cheapest rooms are the ones on the lower level. So first level, cheaper than ones on the second level. But as you go up levels, some of those are exceptions, and we'll talk about a way to figure all that out. So they're cheap, they go to the atomic hotel, they buy the cheapest rooms first. That's what they always do. So here's kind of a picture of what they call the Aufbau diagram, and you can see that different things are, they're kind of, this is to kind of represent the energy level. So I'm going to switch screens here a second and go to this one, and I've got this on here, so I'm working off my iPad, but you can see now that on this level there's my 1S. Okay, that's the lowest one, that's the cheapest. So here's my hotel, and it's kind of a weird looking hotel, kind of shaped kind of funny. But in the first floor, those are the cheapest ones. So the 1S rooms, those are the cheap rooms. Then we go up a floor, 2S is cheap, is the cheapest on the second floor, but notice how it's going to take more energy to go up here. It's going to take a little bit more. And then P sublevel, that's a little bit more energy, and so on. So as you go up this level, you can kind of see this. Now, if you notice what happens here, when you get to like the 3P, and then we go to, normally you might think, oh, well, I'm going to go to 3D, but actually the 4S sublevel is just a little, kind of a little crooked, but just a little bit below the 3D. So once we get to about that high, then we start getting some of these exceptions where they don't always fit in quite perfectly. So we'll talk about how to to calculate all that. But this is the levels that we're going to have. This is what they're talking about when they're talking about Aufbau. So Aufbau is kind of just this graph, this chart that says, hey, we're going to put these sub-levels in for each one. Now think of this, okay? This, I always think of it, and I would kind of draw this just a little bit differently when I do it. So I would kind of draw, you know, here's my first floor, and here's the second floor. That's the 2S, and then I've got, here's my 2P room, and I just do this because I can't draw quite like they do and make it really pretty. So here's 3S and 3P and 3D. There's the 1S and so on. So, you know, I've got these different levels that you're starting to fill in. You got this really weird looking hotel. But in general, to start with, they always go, you know, they go lower levels. But once we start getting up to this area, the 3D, you know, the 4S area, then they start to fill things out of order. And so you've got to be very careful as to how you fill this. So let's go back, go over a few more of these, and we'll come back and make sure we do a bunch of these for practice here. Okay. Actually, let's leave you that way and go like this. Okay. So the next rule was the Pauli exclusion principle, and that says that an atomic orbital can only have 2 electrons. So we talked about orbitals yesterday. You know, the S was the spherical shaped one, can hold 2. We talked about the P orbitals, and they were dumbbell shaped. Now remember, there were 3 of those. Each of those could hold 2. So altogether in P there's 6. Each sublevel could hold 2. And if you have 2 electrons in a sublevel, they must spin in opposite directions. So like one must spin clockwise, the other spins counterclockwise. And they have to do that. That's kind of how they balance that charge. Because think about it, they're both negatives. So it's not, you know, they don't want to be next to each other. So one of the ways that they do that to be stable is they spin in opposite directions. Well, here's my rule for this. Okay, each bed in the atomic hotel can only hold 2 people. So if we have one floor that has, you know, the S room has 1 bed in it, can hold 2 people in it. The P floor, or the P sublevel, the P room has 3 beds in it. It can hold 6 people, or 6 electrons. And this is kind of the weird part about the atomic hotel. If you sleep together, you have to sleep in opposite directions. Then our third rule is Hund's rule, which states that electrons occupy orbitals of the same energy in a way that makes the number of electrons with the same spin direction as large as possible. Now that is like totally confusing if you read it, but basically what they're saying is that they're going to fill separate sublevels first before they start doubling up. In other words, here's probably an easier way to think about it. In the atomic hotel, people don't like to sleep in the same bed unless they absolutely have to. Think about it. You go out with your friends, you know, you got 3 beds in the room, there's 3 of you, you're going to sleep in 3 different beds. If you got a 4th person, now somebody's going to have to double up. And in the atomic hotel, you can't sleep on the floor. It doesn't work that way. Well, we could write, in fact, let's go back and do a few. Let's just take a look at how we would do this if we're talking about some different configurations of things. So if I go back to my drawing here, and let's say that I'm talking about hydrogen. Hydrogen has 1 electron. So if I've got to figure out how am I going to put hydrogen into this, well, the first electron, you remember they're cheap. They always go to the lowest floor, lowest room, and that's the 1s. So the first electron, he's just going to run in and go there. So 1 electron out, he's going to that room. If we have helium, remember helium is 2 electrons, so you're going to have this first one in here, there'd be 1, and then the second one's going to sleep in here in the same bed because they're not going to get another room. You know, if they don't have to. If they can fit there, they're going to do it. But they're going to sleep in opposite directions. So in other words, they're going to have opposite spin when they do this. All right, so let's say that we do Now let's start this over here. Let's just erase these guys. So we start over. And let's say that we're talking now about boron. So boron has 4 electrons. Atomic number's 4, 4 electrons. So the first one's going to come in, and he's going to go right there. So there's 1. Next guy, he's going in here because he's cheap. He's going to the cheap room. 2 guys in that bed. That bed's full. So now you got to go up. Here's the third guy. He's going to go there, and the fourth one's going to go there. So that's where they're going to go if it's boron. Let's say we got carbon. Carbon's got 6 electrons. So we got 2 more that we got to fill in. So they're going to go up to the next level. That's the 2p. Well, we got 3 beds in this room. So the first guy, he's going in here, and he's going, the next one's going, I'm not sleeping with him if I don't have to, so I'm going to go right there. And that's exactly what happens. Now, let's say that we were doing oxygen. Oxygen has 8 electrons. So far, we've got 6 in there. So there's 6. Here's my 7th one, and they're good. They like it that way. And now the 8th guy is coming in, and he's going to figure out where he's going to go. So no matter what, he's going to have to double up. So he's going to go with one of these guys, but he's going to sleep in the opposite direction, or his spin's going to be opposite, and it's going to look like that. Now this is kind of long. I mean, this gets annoying to have to do this all the time. So instead of that, they've come up with kind of a shortcut method for doing that. So let's say that we were talking about hydrogen, our first one that we said, hydrogen, with 1 electron. We're going to say, let's go back, and let's get rid of all these things here so we don't get confused. So I've got hydrogen, okay. He's got 1 electron. It's going to go right there. So this is what we're going to say. Look, we've got the first level, 1, the first sublevel, S, and we've got 1 electron, and we put a little superscript. So we would write hydrogen as 1s1. If we do helium, we said helium had 2 electrons, so helium with 2 electrons is going to be the 1s, but now there's 2, so it's going to be 1s superscript 2. Don't call it 1s squared. It is not 1s squared. There's no squares here. It's just their way of writing. This is a shorthand method. Let's say we're going to do oxygen. Okay, so if we want to do oxygen, let's get rid of these guys. Oxygen has 8 electrons. So there's our 2. Here's our next 2, we said. And 5, 6, 7, 8. So if we want to write the shortcut method for oxygen, what we're going to do is, well, the first level here, that's 1s2. But that's not the end of it. We've got this one. We've got that right here. Okay? So we've got to add that in. 2s2. And then we've got 4 in that P sublevel, 4 in the 2p, so it would be 2p4. So here's my configuration for oxygen. Now notice, if you look at this, there are 2, 4, and 4 more is 8. These numbers here will always add up to be the total number of electrons that you have. Okay, it's always going to be that way. All right, let's go back to the slideshow.